We're going to look at tree traversal algorithms. When traversing a tree, we start at the root node. So this is node number 1, which has a value of 10 at its node. You then visit the node, traverse left or traverse right, and the order in which you do those three things depends on the traversal method that we use. There are three types of traversal algorithms. So we have pre-order traversal, post-order traversal, and in-order traversal. I'm going to begin with in-order traversal, where we traverse the left first, then we visit the node, and then we traverse right. So the order in this example that we would visit them is 1, 10, and 17. And typically we use in-order traversal for ordering a sequence of numbers. Now, if you look at this tree we have here, the way we traverse it, you can imagine putting a dot underneath each of the nodes and traversing clockwise from the root node. You visit them in the order in which you pass through each of those dots. So the first node we would visit would be node 4 that contains the value 3. The second one would be node 2, and the third one would be node 5, and so on. And then we keep continuing until we return back to the root node. The sequence we'd output then would be, in this case, the numbers would be in ascending order from 3 through to 18. At pre-order traversal, we visit the node, we then go to the left and then go to the right. So we're doing in that order. So in this example here, the order we'd visit them would be 10, 1, and 17. And this is for prefix notation or for copying a tree. Now to traverse this tree, what we would do is we'd put a dot to the left hand side of each node, and again traversing clockwise from the root node, passing through each of those dots. We just keep traveling around the tree until we return back to our node. And you can see in this example here, what it's done is it's presented what we call prefix notation. So it's given us prefix notation output there. Then we'll finally look at post-order traversal. In this situation, you traverse to the left, then to the right, and then you visit the node. So in this sequence of numbers, we'd visit them in the order of 1, 17, and 10, and this is used for reverse Polish notation. So here we are putting a dot on the right hand side of each node, and again we are starting at the root node when we traverse this, starting at the root node, we're passing through each of those dots in turn until we get back to the root node, and the sequence output in this case is a reverse Polish notation expression. Now I'm going to just quickly look at the comparison between the three algorithms. They look really similar. The main difference is where we place the output. So the print statement, you can see in the in-order traversal, it is between the two recursive calls to in-order traversal there. So it's between, so the output is between the recursive calls. For post-order traversal, the output is after both recursive calls. So these recursive calls will be the general cases in both those cases. And then we have pre-order traversal, where our output is before the call, the recursive call to pre-order traversal. So that's the distinction between the three algorithms. Later on, I'm only going to trace in-order traversal just because they are very similar, except of course just where the print statement is placed within the function. Here is the complete code for the in-order traversal. This is the code that we are going to trace. So we have the in-order traversal function there. You can see the two base cases there, and you can see that it's recursive. On the right hand side, we have the tree that we're going to apply this algorithm to, and that's represented as the three lists on 8, 9 and 10. So line 8 is the list that represents the values themselves of the nodes. You have then the pointers or the reference to the tree left and to the tree right. So that's indicating the reference of the nodes. The -1 indicates that there is no other node coming off of that tree, either going to the left or to the right. So if a node has a left tree and a right tree pointing to -1, what that indicates is that it's a leaf node and there are no other nodes coming off of that node. So you can see, for example, that nodes 3, 4, 5 and 6 with values 5, 8, 11 and 18, they have all pointers to -1, which means that they are leaf nodes. On lines 2 and 5, this indicates that we will only call the recursive in-order traversal function only if the node is only if there's a node pointing to another node, only if there's a reference to another node. So if it's suggesting that it's a leaf node or a node that has nothing pointing to it, it will not call the recursive function, either going to the right or going to the left. We're going to trace the in-order tree traversal algorithm using the code presented here. On the top right hand corner you see the tree that we're going to trace, and you can see on lines 8, 9 and 10 a representation of that tree as three lists. You've got the list for the values of the nodes themselves, and then you've got the left and the right pointer lists to the nodes. Now you can see that the function for in-order traversal is recursive, and it has two base cases, and you can see the output there is between the two base cases. So we start on line 11. We call in-order traversal on node 0. So this is our root node. And we just record in our table, we record the value of our node there, so which is 10, and we record the nodes to which it points to, which is 1 and node 2. We check then to see if our tree left node doesn't equal -1. Well, tree left node is 1, so therefore it doesn't equal -1, so therefore it's true. So we are going to execute line 3. So on line 3, we make a second call to in-order traversal using tree left node. So that now is value 1. So within that second call, we check to see if tree left node doesn't equal -1, which it doesn't because it's equal to 3. And so now we execute the next line on line 3. We make a third call to in-order traversal where the parameter for the tree left node, so the node value that goes in there, is 3. Going into that call to that function, check to see if the node doesn't equal to -1, which is now false. So therefore, we do not execute line 3. We move to line 4 here, and we output the value of the node here, which is 3. Check to see if our tree right node doesn't equal -1, which is also false. And so jump straight to line 7, and we can see there that we have terminated that call 3. So now we're back in call 2 and we return to line 4 here. Here now we're outputting the value of the node, which is now 4. We check to see if our tree right node doesn't equal -1, and that's true. Therefore, we execute a 4th call to in-order traversal using the value of the tree right node, which is 4. So now we're inside call 4. We check to see if our left tree node doesn't equal -1. Well, our left tree node does equal -1, therefore we skip to line 4. On line 4, we output the value, which in this case is 8. We check to see if our node to the right doesn't equal -1. Well, that's false. And so we return from our call number 4. So we finish in call number 4 and we return to call 2. Now we're on return on call 2. That's where we're returning to. So now we return straight from call 2 back to call 1. In call 1, we return to the output. So we output the values there, which was 10 that was stored there. And we continue within call 1. So if tree right doesn't equal -1, which is true. So now we make another call to in-order traversal. This is the 5th call to in-order traversal, and we're using the value, the node value of 2. So inside that function call, we check to see if the tree left node doesn't equal -1, which is true. Therefore, we make a 6th call to in-order traversal using left tree node here, which is what we're going to use as our value, which is 5. Next, within call 6, we check to see if our tree left node doesn't equal -1, which is now false. We go to line 4, we output the value here, which is 11. We check to see if our tree right node doesn't equal -1. That's also false. We return from call 6 and we return control back to call 5. In call 5, we output the values of our node, which is 17. On line 5, we see that our tree right node value is 5, so therefore the if statement evaluates to be true. We then execute line 6, which is an additional call now to in-order traversal. So we're now on call 7 to in-order traversal. Within order traversal, we are using as our parameter value here. Parameter value is now -1. Now here, our -1 doesn't equal minus, so therefore this statement on line 2 is false. We therefore proceed to line 4, where we print out the value of the node, which is 18. We then evaluate whether tree right node doesn't equal -1. Well, that's also false. We return from call 7 back to call 5, and we return directly back from call 5 to call 1, and then we finish with call 1 as well. And at this point then the program terminates.